Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a quadratic pattern, and let's get straight into it. So they've said to us, consider the quadratic pattern 3, 5, 8, 12. Now, by them calling it a quadratic pattern, they've already given us a clue as to what to expect from this pattern. When we deal with a quadratic pattern, we know to expect a second common difference. So that's one way we can check that we're doing the right things. So they've said to us, determine the value of the 26th term in this pattern. Now, if you think about it, we can fill out the terms up to 26, but that's going to take some time, and you probably don't have the time under exam conditions. So the quicker way of doing this is to find a general term and then plugging in 26 into the nth position, and that will give us the answer that we're looking for. So with that in mind, let's dive straight in. So I'm going to rewrite the sequence. Right, and the very first thing I'm going to do is check for the first difference, and the first difference here is going to be 5 minus 3, which is 2. Then the 8 minus 5 gives me 3, and then the 12 minus 8 gives me 4. So that's my first difference, and we can see quite clearly that it isn't common. We then have a look at our second difference. So 3 minus 2 gives us 1, and 4 minus 3 gives us 1, and just as we expected, we can see that the second difference is constant, and that's exactly what we'd expect from a quadratic pattern. Now, we're going to use these very useful differences, as well as the first term of the sequence, in order to generate our general term. All right, so let's have a look. We know that the first term must equal A plus B plus C. And remember, where are these A's, B's, and C's coming from? We are looking to build something that looks like this. Tn is equal to an squared plus bn plus c. So that's where the a, b, and c are coming from, okay? So with that in mind, the a plus b plus c is equal to the 3, so that's the first term of the pattern. Then we know that 3a plus b is equal to the first difference, the very first term of the first difference sequence, so that's going to be the 2, so that's that one there. And then finally, we know that 2a is going to equal 1, which is the first term of our second difference, which is common. Right, with that in mind, we can start by simplifying for a, then plugging the a in there to solve for b, and then plugging the a and the b in there to get our c. That will then generate our general term, after which we can plug in the 26 to get the 26th term in the sequence. So if we look at a, we know a is going to be a half. So if we plug a half in over here, we can solve for our b. And the b here is going to be a half as well. So 3 times a half is going to be 1.5. Take that across, 2 minus 1.5 is going to give us b equals 1/2. And then finally, we can now plug in our a over here. So that's half plus a half plus c equals 3. So that's going to be 1 plus c, so c is therefore going to be 2. So now we have generated the coefficients that we can plug into our general term formula. So the a we know is a half, so that's a half n squared plus a half n plus 2. So that gives you a good amount of information. Now we can use that in order to calculate our 26th term. So we're going to say T26 is equal to 1 over 2, 26, and that is squared, plus 1 over 2, and that is 26 times 26, plus 2. And when we plug all of that into our calculator, we're going to find that T26 is equal to 353. So that means the 26th term in this particular pattern is equal to 353. Thank you so much for joining us. Thank you so much to our sponsors for making this video possible. It's really, without them, this would not be possible. So it's really great that they're on board. Feel free to read all about them in the description below. Also, head over to our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.